Feel free to pause the video and figure this out yourself. Find the equation of the ellipse whose vertices are 3, 4 and 13, 4 and whose eccentricity is 1/5. So basically now, these are what problems involving ellipse. You won't have the equation, but instead you'll be required to find it. So what do you do? Now, if you have the vertices and you are required to find the equation of the ellipse, then the first thing I would suggest you consider doing is finding the center of the ellipse. Because remember, the equation of the ellipse would either be x squared over a squared plus y squared over b squared equals to 1. Or it should be the one that is not centered at origin, x minus h all squared divided by a squared plus y minus b, b, y minus k all squared divided by b squared equals to 1. So if you rather be any of this, but still remember, if it's not a horizontal orientation, if it is vertically orientated, the value of a and b to be changed. So you need these two things. You need to know the ellipse you are dealing with. One, and sometimes you need the center of the ellipse. Either it is the coordinate of the vertices they give you or the coordinate of the foci. This method I want to show you now will definitely works. And that's the best thing I would suggest to consider putting into account first. So first, let's find the center. After we have the center, let's know about the ellipse. To get the ellipse, look at these two coordinates given to us. We can use them to get the center of the ellipse. We are given the vertices, but they didn't tell us maybe it is major vertices or the minor. If they didn't specify, consider it as a major, because that is the most often given. Am I communicating? That's the most often given. Only if they specify that it is minor, that's when you consider that coordinate as minor. And in fact, even if it is minor vertices it gives us, this will still help us. It will still help us to get the center of the circle. So why am I mentioning the circle of the ellipse? Are we there? Perfect. So we'll actually learn coordinate geometry. When we have two coordinates, we can determine the coordinate of the midpoint of the line segment joining the two coordinates. Now remember, let me show you an actual illustration of what I'm saying. Ellipses. Is that an ellipse? Let's work with that. This is an ellipse, for instance. We said if it is horizontal in nature, this point and this point, we say they are the coordinates of the major vertices. Okay? Now, the line that joins these 2 points, if we find it's the coordinates of the midpoint of the line that joins these two midpoints, if it is somewhere around there, doesn't that coordinate correspond to the center, the coordinate of the center of the ellipse? It does. You feel me now? Exactly. So that's what we are trying to do. We are trying to find the coordinates of the midpoint of the line segment joining the two coordinates we have here. Because that coordinate of the midpoint of the line segment joining the 2 points will correspond to the midpoint, or will correspond to the coordinates of the center of the ellipse. Am I communicating? So that's what we are trying to do. So basically now, to get the coordinates of the midpoint, what do? The formula is such that the coordinate of the midpoint, x, y, is equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2. So x1 is the first one, y1 is second one, x2 is second one, y2 is second one, third, fourth, to see next sense. So x1 is 3, x2 is 13, y1 is 4, y2 is 4. 13 plus 3 is 16 over 2. 4 plus 4 is 8 over 2. So we have 8,4. So this is the center of the ellipse. Am I communicating? Perfect. Now that we have the center of the ellipse, are we required to find the center of the ellipse? We are not, but we have given them bonus. We find the center of the ellipse for them. So C is 8,4. That's okay. Now, that one that we have C, we clearly know that the ellipse is not centered at the origin. It means this can never be an equation of the ellipse. So it will be this one. Now, will it be this one? Will it be this one? Or it should be this one? X minus h all squared divided by b squared plus y minus k all squared divided by b a squared. So it must be one of these two. To now know which is going to be equals to 1, I have which is equals to 1, equals to 1. To now know which is going to be next sense, you must know your ellipse. And the question is, how do you know your ellipse? I even expect you to know how you can know your ellipse, because it's part of, when I was disclosing the concept, I actually made mention of it, that if you are given the vertices of the ellipse, you can use it to know the type of ellipse you have. Yeah, let me call it for you. You pay attention to the vertices value. If you look at the coordinates of the vertices, which axis tends to be having the highest value? Look at it. 3,4. Though 4 is more than 3. But when it comes to the other one, we have 13,4. Far away. X-axis is having more value. That tells you that it's a horizontal orientation ellipse. Am I communicating? No matter what, that is enough for you. One of those coordinates will have the highest. You understand? If it's y part that is having the highest, it means it's a vertical orientation. You get my point now? Even without carving your ellipse, you can use this to know what type of ellipse you are getting with. So this ellipse is actually horizontal in nature. Thus, this is the best one to use. So the largest value will be under x. Are we here? Now that we have the center, the equation will be x. Now, if you have the center and you want to put it in the equation, you have to alternate the sign. Remember, if you have the equation, you want to put it as a coordinate center, you alternate the sign. It is vice versa. So it is 8 before. When it's going right in the equation, it becomes minus 8. So minus 8 all squared divided by a squared. We get the value of 8 on 1. A squared plus y minus k is what? 4 all squared divided by b squared equals to 1. Good. We are on the safer side now. We are moving forward. The goal now is to get the value of a and b respectively. So what do we do? Well, we are given eccentricity. E, lowercase e, let me have that in black, is equal to c over a. How do we get c? That is the question. What do we do to get the value of c? So what do you think? Since we have the coordinates of the vertices, we can actually get that length. You know, what we did here was that we actually got the coordinates of the midpoint of the line segment joining the 2 points. What if you want to determine the magnitude of that line? Let me show you what I'm trying to explain. Makes sense. You know, if this is the ellipse now, you said from here to here, this is the first point. Let's say, okay, there's 3,4. While the other one, we said that's 13,4. Good. So now, right now, we said, okay, we use the midpoint formula. We use that to get this one. And we got that as 8,4. Remember, we said from the center of the ellipse to one end of the ellipse along the major axis is the value of a. And same thing applies, negative a for the left hand side. Can we have this point, we have this one. Can we use the distance formula to get the value of a? Yes, we can. Because we have the 2 coordinates. You understand? And if you don't want to do that, you can get the distance from here to here divided by 2. You must get the same value of a. You get me now? Because initially, my own mind is that I want to do this and this. I will get the length, then divided by 2. But upon showing the visual illustration now, I realized that we can actually use this and this and get the value of a. We will still get the same answer. And that's what I'm going to use. I don't want to divide by 2. Okay? If you want, you can divide it by 2. So now basically, what does this distance formula says that? It says, okay, the magnitude of the line joining 2 points, let's say the value of a, magnitude, is equal to the square root of the square of the difference between the 2 corresponding coordinates, x2 minus x1 all squared plus y2 minus y1 all squared. Clear that with me? Okay. So let's put the values. Square root of x2, this can be x1, x2, this can be y1, I made a mistake. X1, Y1, X2, Y2. So that's going to be X2 is 13. 13 minus 8 all squared. Then plus Y2 is 4. 4 minus 4 all squared. So that's going to be 13 minus 8. That's 5. Yeah, that's 5. And it means the value of A will be equal to the square root of 5 squared. 4 minus 4 is 0. 0 squared is 0 plus that's gone. The root of 5 squared is 5. So 5 squared is 25. The root of 25 is 5. So that's equal to 5. The value of A is 5. Now, E is equal to C over A. That's very good. We can now get C. Since E is given as 1 over 5, it means 1 over 5 is equal to C over A is what? 5. Now, upon cross multiplying, you can see that C will be equal to 1. How? If I cross multiply, I have 5 times 1, which is 5, to be equal to 5C. Dividing 2 by 5, C will become 1. I have that. Am I communicating? Good. Now, let's get the value of B using C squared equal to A squared minus B squared. So now this can go. Now I said C squared equal to A squared minus B squared. C squared will be 1 squared. A squared will be 25 minus B squared is what we are looking for. We bring it this, we have B squared equals to 25 minus what would that be? 25 minus 1. And B squared will be equal to 24. Perfect. Now we have the value of A and B respectively. We can now get our equation in the very best form. Thus, the equation of the ellipse will now be, now instead of A squared minus B squared, I still want to use this one. Now just get rid of the two of them and put the actual answer. So A squared is 25. So we have 25 plus B squared is 24. And this is the equation of the ellipse. That has its eccentricity to be 1 over 5 and the coordinates of the major vertices to be 3,4 and 13,4. So that's it, guys. On to example number 4.